Okay, Algebra 1 students, in this video, we are going to finish our lesson on fractional exponents by going over some notes to your future forgetful selves. So on this side, I have several facts that I want you to know written in words. And on this side, I drew pictures to represent the statement that I made on this side in words. This is using symbols, okay? So the first thing I want to tell you is fractional exponents are roots. It is another representation of a root. And remember, a root can be an irrational number if it's not a perfect square. If it's a perfect square, like 4, 9, 16, 25, etc., it is a rational number. But if it is not a perfect square, it's an irrational number. But it's still real. Okay? So instead of using a radical sign, you can use a fractional exponent. Okay? So that's what this symbol picture goes with this first bullet point. It says that if I have a number a to the m over n power, I can write that two different ways. Okay? I can write it underneath the radical sign as a to the mth power, and we're going to take the nth root of it. I can also write it with the power outside the radical. So I can just have a underneath the radical sign, and I'm taking the nth root of a, and then I'm going to take this number and raise it to the mth power. Both of these are correct. All three of these forms are equivalent. Next, the denominator of the fractional exponent is the root, and the numerator is the power. This symbol picture goes with that bullet point. Okay? If I write a to the m over n power, the numerator m is the power and n is the root. Next, you may not take an even root of a negative number. Okay? So let's look at these two pictures that illustrate this point. Here is I'm taking the fourth root of this a, but you can see that it's a negative a. So that's why I've got the red circle with a line through it saying no, you cannot do this. Why? There is no number that when you multiply it, there is no negative number that when you multiply it an even number of times, that will give you a negative number. That's not how numbers work. It just so happens this is a number. It's just not a real number. It's an imaginary number. And you learn about them in detail in Algebra 2. And I introduce them to you while we're doing our quadratics unit, and we plant seeds for our Algebra 2. But we don't learn about them in detail. Okay? We can take the odd root of a negative number. For example, the third root or cube root of negative 8. That is negative 2 times negative 2 is positive 4, And positive 4 multiplied by negative 2 is negative 8. Okay? And last but not least, here is how you take the square root of a variable. All right? These two examples on this side go with this instruction. So let's look at the words first. So what it says is you find the largest even power and then you divide it in half. And you write that variable on the outside of the radical. Here's an example. Example number 1, x to the third power. Well, what's the highest even power I can take out of there? X squared, right? X squared times x to the first power is x to the 2 plus 1, or x to the third. Okay? And the square root of x squared is x. So I write the x on the outside of the radical sign, okay, because just like a perfect square, I'm using it to simplify. And so now what do I have underneath the radical sign? A single x. So now let's do x to the 7th power. So what's my highest even power? It's x to the 6th times the square root of x. And half of this is x cubed. Notice how I have pulled this x cubed out from underneath the radical sign. So now it's on the outside. And on the inside, I've got my single x. It's as simple as it can be now. If you look across the top and you look at this light blue that I wrote up here, this is an illustration of why this finding the highest even power and splitting that number in half, this is why it works. So you can represent x to the 6th as x times x times x times x times x times x, right? 6 x's in a row. Well, we could separate those so that we have x to the 3rd times itself, right? X to the 3rd times x to the 3rd is x to the 3 plus 3. You add the exponents when you're multiplying by the same base. So that gives us x to the 6th. So there you go, young people. This is how fractional exponents work on our basic Algebra 1 level. And I hope you found this video helpful, and I will see you in the next one.